Water flow management methods or devices. Water-lifting devices. Ancient civilizations developed various water-lifting devices, such as shaduf, windmill or Archimedean screw, in areas where water sources were at lower elevations. These devices allowed for the efficient lifting of water to higher levels for irrigation purposes. Ancient Chinese developed pumping stations to uplift water. Today water tanks, pumping stations, and pipes are used for the same purpose. Water mills were widely used in medieval Europe, for milling grain and performing various industrial tasks. By strategically placing water mills along rivers, communities could harness the power of flowing water, concurrently helping to control water levels. As the power of the water is extracted for commercial purposes, the force of water will be reduced, reducing the soil erosion. We could exploit the power of rivers today to meet some of our power needs. The power of the flowing water is not fully exploited till today. Even though hydroelectric dams around the globe exploit a part of the power of the water, but still a lot of power is there to be exploited still. We are not yet fully realized the full potential of hydroelectric power production using mini, micro, and vortex hydroelectric power production. Weirs, sluices, and gates. Weirs, sluices, and gates used to control the flow of water. Weirs are low dams that are used to raise the water level in a river or stream. Weirs were constructed across rivers, to regulate water flow and facilitate irrigation. Ancient Chinese societies used different types of weirs, to control water levels and distribute water to agricultural fields. Sluices are gates that are used to control the flow of water through a dam. Cascading connected tanks, which emerged in Sri Lanka as early as 5th century BC, used canals and sluices to connect a series of tanks. Gates are used to open and close a channel, allowing water to flow through or to be blocked. They are useful especially in field channels to control the water supply to crops. Fish weirs are structures placed in rivers or streams, to control the movement of fish. It facilitated fishing but also influenced water flow and flood management. In addition to their role in fishing, ancient European communities used fish weirs and traps in rivers, to influence water flow. These structures were sometimes designed to redirect water and mitigate the impact of floods on nearby settlements. Ancient Chinese used different types of weirs, to control water levels and distribute water to agricultural fields. Traditional weirs were constructed by ancient Chinese societies, across rivers and streams, to regulate water flow and facilitate irrigation. They regulated water flow and were designed to trap sediments, enhancing soil fertility. Weirs are structures that also helped to control water flow and allowed for sustainable fishing practices. African societies used fish weirs and traps in rivers and water bodies. These structures not only facilitated fishing, but also influenced water flow and flood management. Australian indigenous communities often constructed fish weirs, which were structures placed in rivers or streams to control the movement of fish, as a means of obtaining food. Traditional fish traps built in rivers and waterways, by Aboriginal communities while not for the purpose of flood management, played a role in changing water flow, contribute to managing river dynamics and had environmental implications. Ancient Indian civilizations also built weirs, sluices, and gates to control the flow of water. Originating during the Eastern Han Dynasty, the Dragon's Gate water control system was a series of gates and channels designed to manage water flow and prevent flooding along the Min River in Fujian province. This system achieved water management and flood management by dividing the river rather than constructing big dam to halt the river flow. All these structures may also be useful in generating electricity using mini or micro hydropower generators. Reservoirs, tanks, dams, check dams. Reservoirs and tanks are used to store water and minimize flood. They stored water during rainy and snow-melt seasons. They provided water during dry seasons for irrigation, domestic, industrial, commercial and religious use. Ancient civilizations around the globe used many kinds of reservoirs for storing water. Reservoirs are still used for storing water. Dams are built across rivers to control the flow of water and protect the settlements from rivers. For example, the dams reduce the destructive force of the Yellow River. This practice was used by ancient populations in Peru, Mesopotamia, Middle East, China, India and Africa. The dammed water is very useful during dry seasons for irrigation, domestic, industrial, commercial and religious use. Reservoirs and dams were built in the foothills of the Himalayas, where they could capture the monsoon rains and store them for later use. Check dams constructed across smaller streams and tributaries to slow down the flow of water and to trap sediments. These structures contributed to soil conservation and helped to regulate water flow downstream, reducing the risk of flooding. Cascading connected tanks collected and distributed water over a wide area of land. They stored water during the period of abundance and distributed water when it is needed. They helped in reducing the effects of floods and droughts. Cascading connected tanks are a hydraulic engineering wonder from ancient Sri Lanka. They are still used in different parts of the world. You can look at reservoirs in the full article dedicated to reservoirs in our website. Floating gardens and chinampas. Flood-prone areas, such as parts of Assam, communities created floating gardens called fundis to cultivate crops. These floating gardens rise and fall with the water levels, allowing for sustainable agriculture in areas prone to inundation. This water management strategy allowed them to produce crops even during the floods. Aztec civilization, dominant in Mesoamerica, central and southern Mexico, from 1300 to 1521 CE developed a unique agricultural technique known as chinampas, artificial farming islands. These floating gardens were constructed in the marshy areas of the Valley of Mexico, serving both as a form of land for agriculture and flood control. They are constructed on mats of vegetation. Chinampa agriculture allowed communities to grow crops even during periods of high water levels. These rectangular plots of land, constructed on marshy lakebeds, were elevated above the water level using soil, reeds, and other organic materials, were used for intensive agriculture. Chinampas were supported by a complex system of canals for water management. The chinampa system provided fertile soil and a controlled water environment, allowing for the cultivation of a variety of crops, including maize, beans, squash, and tomatoes. Floodways or diversion channels. Diversion channels, also known as floodways, are usually man-made channels that are designed to divert excess floodwaters away from populated areas. These channels can be natural or artificial, and they can be temporary or permanent. Diversion channels were used in ancient civilizations to protect settlements and populated areas from flooding. They can also be used to divert water from agricultural lands. They could mitigate the impact of floods on communities, infrastructures, commercial and industrial complexes and agricultural lands by controlling the flow of water. Some of them are still in use today. Today pipes are used to redirect water away from settlements, populated areas, agricultural lands and infrastructures in many places. But some countries still use canals as diversion channels. Ancient Middle Eastern engineers constructed diversion channels that directed excess water away from populated regions, reducing the risk of inundation. Ancient American civilizations like Maya and Inca used to divert floodwaters away from settlements to ditches built in the banks of rivers to divert floodwaters into reservoirs for future use. Ancient civilizations in many parts of Africa including Egypt, Ethiopia and Nigeria used canals as floodways to divert floodwaters away from settlements and agricultural lands. Canals also helped in irrigation. Canals and irrigation systems in some parts of ancient Indian civilizations used to redirect water from rivers into tanks for future domestic and agricultural use, thus preventing floods and droughts. The huge tanks discovered around the ancient settlements is probably a testament to this. Ancient Sri Lankan civilization used diversion channels to redirect water to cascading connected tanks, to prevent flooding by storing water for future use. From 2nd millennium BC, Chinese engineers constructed intricate diversion channels to redirect excess water away from settlements and agricultural land. These channels helped to distribute water more evenly and reduce the risk of flooding in vulnerable regions. Levees, dikes, embankments, bunds, banderas, and bisecotuva. Levees are raised embankments that are built along the banks of rivers and streams. Dikes are similar to levees, but they are typically smaller and are used to protect smaller areas, such as individual farms or homes. Levees are designed to prevent floodwaters from inundating land and protecting settlements from flooding. Levees were used in ancient Egypt, Mesopotamia, and Rome, and they continue to be used today. Many European civilizations, especially those residing near rivers prone to flooding, constructed dikes and levees to control water levels. In the Netherlands, an extensive system of dikes and levees has been developed over centuries to protect low-lying areas from flooding. Most common structural measures used to manage floods in India was the construction of earthen embankments, known as bunds. Ancient Indian civilizations built earthen embankments known as bunds or banderas in regions prone to flooding. These structures served to control the flow of water and to prevent flooding. Bunds were built along the banks of rivers and streams to divert floodwaters away from settlements and agricultural land. They were often very large and complex structures, and they required a great deal of labor to build. They were often constructed along rivers and streams to protect agricultural lands. These bunds acted as protective barriers, preventing floodwaters from inundating agricultural fields and settlements. They were sometimes reinforced by growing Indian basil on top of them. Indus Valley Civilization embankments were strategically constructed along the banks of rivers like the Indus and Saraswati. The construction of levees and embankments along riverbanks was a common practice in ancient China. These structures were built to contain river water during periods of high flow, preventing floods and protecting nearby settlements and farmlands. Ancient Middle Eastern civilizations also built levees and dikes to protect their settlements from floods. Ancient African civilizations built levees and dikes to protect their settlements from floods. Levees and dikes have been found in many parts of Africa, including Egypt, Ethiopia, and Nigeria. The ancient Egyptians built dikes along the Nile. Aqueducts. The Romans, known for their advanced engineering, developed aqueducts to transport water over long distances. While primarily designed for water supply, these aqueducts also played a role in flood control by managing water flow and preventing inundation of urban areas. Amphitheaters for flood-prone area management. Amphitheaters were often strategically located in low-lying areas that were prone to flooding, in ancient Greek and Roman cities. The design of these amphitheaters allowed for efficient drainage during heavy rains, serving a dual purpose of entertainment and flood management by acting as a receiver for flood waters. Draining and sewer systems. Advanced drainage and sewer systems helps to remove wastewater and manage storm water runoff. These systems included underground channels and conduits designed to carry rainwater away from populated areas, reducing the risk of flooding. Draining and sewer systems are used by many ancient civilizations. Its use is visible in the artifacts of ancient American, European, Middle Eastern, African, Indian, and Chinese civilizations. Draining and sewer systems are a necessary part of most modern cities and villages. Countries like China even come up with the roads which are porous to collect water to remove water fast into water recycling systems. This collected water will be useful in cities and villages for many purposes. Cities can use the flow of wastewater in the sewage and draining systems to produce electricity using newer small hydropower generators. Regions with water scarcity can benefit from rain or snow melt water collection from the roof and reuse. Rain or snow melt water collected into the ponds, tanks and wells constructed for the purpose can refill the aquifers underground to reduce the water scarcity in arid regions. This is done in Chennai, in India, which suffers from water scarcity in the summer months by house owners. Anicuttes. Anicuttes, or ancient water regulators, were constructed across rivers and streams to regulate water flow. These structures helped to control floods by diverting water during heavy rains. Anicuttes were used to divide a river into many canals and directing the canals to the places like agricultural fields where it is needed. Kalani Anicut is the fourth oldest water diversion or water regulator structure in the world and the oldest in India. It is still in use. This Anicut, along with its canals, ponds and fields channels, provided water for a large arid region of South India for more than 1800 years. At the same time reducing the chance of inundation downstream. The full spectrum of benefits of Anicuts along with its canals, ponds and field channels is multifaceted. The field channels help to irrigate millions of acres of land, reducing the destructive effect of water shortage on crops. They also help to reduce the effect of droughts. The Anicuts along with its canals, ponds and field channels can capture excessive water released through rainfall, so reducing the chances of inundation in settlements and agricultural lands. If we use all Anicuts, canals, ponds and field channels to produce electricity, then hydroelectric power production in the region can be increased. Cadins. In arid and semi-arid regions, communities developed the Cadin system, which involves the construction of embankments called Cadin bunds to capture and store rainwater. This traditional community-driven water harvesting method helps to recharge groundwater and provides water for agriculture and domestic use. Cadin system reduces the chances of inundation in the low-lying areas. Natural or artificial wetlands. Wetlands are areas of land that are saturated with water for at least part of the year. They can play an important role in flood control by absorbing and storing excess water. Wetlands can be artificial or natural. Artificial wetlands can be created by designating low-lying areas in a region as wetland and redirecting excess water from the farmlands and built-up areas all year round. Terraced fields. Terracing prevents soil erosion, landslides, reduce the effect of flooding due to water runoff, and allowing for the cultivation of crops on steep terrain. Terraced agriculture was employed in hilly, mountainous or sloped regions, to slow down water runoff and to prevent soil erosion. This technique involved creating leveled steps or levels on hills, allowing for more effective water management by capturing and retaining water and reducing the risk of flooding caused by water runoff. Terraces helped retain water on slopes, giving more time for soil absorption of water and for refilling the underground water resources, reducing the impact of flash floods and providing additional land for cultivation. Ancient Chinese, Inca, Greece, Africa, Rome, and Indian civilizations used terraced land for cultivation. Basmati rice cultivation in the terraces of Himalayas make use of mineral-rich water running down from the Himalayan mountains. Raised fields. Ancient Japan, Korea, Kerala in India, particularly in low-lying areas prone to flooding, constructed rice paddies with raised edges to control water levels. This traditional method helped to regulate water flow and provided optimal conditions for rice cultivation. The ancient Tiwanaku and Inca civilizations constructed raised fields. These fields were elevated above the water level and allowed for efficient drainage during heavy rains. The elevated fields also helped to prevent waterlogging and soil erosion. Aquatic plant management. Aboriginal communities is engaged in the management of aquatic plants, which could impact water flow. It involved selective harvesting or other practices to maintain a balance in water ecosystems. Cleaning the waterways to avoid blocks to the water flow in the channels and canals is still practiced in some countries. Clearing the debris from the sewage pipes are usual in many cities and villages. This practice will help to avoid flooding in built-up areas during rainy or snow melt seasons. Aquaculture. Indigenous communities in South America often integrated floodplains into their livelihood strategies. They developed fish weirs and other fishing techniques to harness the seasonal floods for fishing and created artificial ponds for aquaculture. Such practices can also impact the water flow and reduce the chance of flooding. Continued in Part 2.